Geography is frequently mistaken for a collection of static facts, capitals, mountain heights, and river lengths. In practice, it functions as a rigorous science focused on decoding the patterns of the Earth's surface. To analyze these patterns, the discipline relies on three specific questions. What is the phenomenon? Where is it located? And the most critical step, why is it there? This approach is rooted in the study of areal differentiation. It is the foundational principle that the Earth's surface is a mosaic of shifting physical and cultural phenomena, which vary significantly from one region to the next. We can see this in action by plotting the locations of commercial wheat farms on a standard map. This addresses the what and the where of our inquiry. Identifying these clusters is only the first step. For a geographer, the real work begins with identifying the specific drivers that forced these farms into these exact locations and nowhere else. The primary tool geographers use to identify those drivers is Geographic Information Systems, or GIS. This flowchart illustrates the system's core logic. GIS organizes geographic information into discrete, transparent layers of data. By isolating variables like street networks, buildings, or vegetation, we see how they interact. This reveals correlations often obscured on a flattened map. We can replicate this same logic manually to find the correlations behind our wheat farm distribution. Returning to our original distribution map, we will tilt the perspective to create a vertical stack for our data layers. First, we examine physical geography. Natural variables determine where a crop can biologically survive. Here, we add a layer showing average annual rainfall and specific soil composition. Next, we add human geography. Economics and infrastructure dictate where a farm can actually reach its customers. This layer adds major highway networks and regional markets to the stack. With the data integrated, look closely at where our original farms are located. Notice the specific zones where the green dots, the rain-heavy blue zones, and the red highway lines perfectly align. The pattern shows a clear causal relationship. These farms require a specific physical environment to grow, but they are tethered to the highway network to ensure their harvest can reach a market. This spatial logic applies to almost any phenomenon. Consider these three separate datasets: regional elevation, historical migration routes, and the current layout of a major city. Stacking these into a single cohesive model allows us to see how they influence one another. This synthesized view shows that the city's historical growth was not random. Its diffusion followed the path of least resistance dictated by the physical topography of the valley. You can use this four-step framework for any geography topic. Identify the what, map the where, stack the physical and human data layers, and find the correlation to explain the why. Mastering this framework allows you to look past the surface of a map and see the world as a transparent stack of systems, revealing the logic behind the location of everything around you.